Question one. A company makes cylindrical vases. The capacity in cubic meters of a cylindrical vase the company produces is given by the function C of x equals, and then we got the equation, where x is the radius in centimeters, the area of the circular base of a vase in square centimeters is given by the function a of x equals 3.14x squared. To find the height of the base, we're going to add, subtract, multiply, or divide the expressions modeling functions c of x and a of x. So this problem is a mouthful. But let's start by drawing a picture. The company makes vases and they are cylinders. So here is my cylinder. Right there. There's better curved bottom there. So they tell us this first equation, C of x, is the capacity. In other words, capacity, synonym for volume. How much stuff would fit inside of this cylinder? It's helpful to know the volume of a cylinder formula. If you're like me, typically I don't have these memorized, so Google is your friend here. Volume of a cylinder formula is pi times the radius squared times the height. So again, this represents the capacity, or in other words, let me circle it in blue, this equation right here, 6.28 x to the third plus 28.26 times x to the squared. Other part of the problem represents the area of the circular base of a vase. So this represents the area of the base. So in other words, the area of a circle. Area of a circle formula you might know. If you don't, look it up. Area formula for a circle is pi times the radius squared. And again, that's represented by a of x equals 3.14 times x squared. The first part of this question wants us to find the height of the vase. Well, something I want to point out here. Notice the area of the circle has a pi r squared, and the volume of the cylinder has a pi r squared. So if we took these two formulas, first let's take the volume, pi r squared times height, and we divided it, again, top one, this is the volume, the bottom one, this is the area. And if we divided it by the area formula, pi r squared, what would happen? Yeah, those pi r squareds, they would cancel out completely, and we'd be left with the height, which is what they want us to find here. So, the answer to this first part of the question, to find the height of the vase, we're going to divide the expressions modeling c of x and a of x. The second part of the problem just wants us to find the expression. So here, I'm going to clear everything out. We actually want to do that division. We want to take the top equation, 6.2x to the third plus 28.26x squared, and we want to divide it by the bottom equation, which is just 3.14x squared. First, this question looks a little daunting with all the decimals, but what I notice is this. I notice that 6.28 is just double 3.14. So I'm willing to bet, so that means we can divide those two. 6.28 divided by 3.14 is just going to be 2. But what I'm willing to bet is that this top number is also divisible by 3.14, but that I need to use the calculator to verify. So let's take 28.26 and divide it by 3.14, and we get 9. Just kind of like we thought there. So what I'm going to do is I'm going to rewrite this problem as two separate division problems. So I'm going to take 6.28. We could also factor the numerator, but I'm going to do it this way. I'm going to rewrite it as two separate fractions, which means it's just going to be two separate division problems. And then let's pick a different color. Let's pick purple to simplify it. So 6.28 divided by 3.14. These are just going to divide out, and this top number is going to become a 2. X to the third divided by x squared. When you divide variables, you subtract the exponents. So 2 of these are going to cancel out, and just 1 of these is left. So this first expression leaves us with just 2x. The second one, and I left off the 3.14 here. The second one, 28.26 divided by 3.14. We just said that was 9. Anything divided by itself becomes a 1 and just cancels out. So we're left with 2x plus 9. Let's say a little prayer and hope that 2x plus 9 shows up in one of our choices. It does.